Okay, in this video, we are going to be doing some volume problems. We're going to draw the region, use the disk method to find the volume when rotated about the x-axis. So there's going to be a link below to the source of the problems. It's from OpenStax Calculus Volume 2, Section 2.2. Let's get started. So I'm actually not going to draw the regions. I'm just going to use an online tool to graph them because that's not really the point of the video. I want to set up integrals and do the integrals. So we have 74, x plus y equals 8, x equals 0, y equals 0. So we want to sketch this. I always need it to be equal to y to really get a feel for it. So y is actually 8 minus x. Here's our region. It's this triangular region. We're going to go around the x-axis. And so we're going to just be doing pi and then the integral from 0 to 8 of we have this radius goes from y equals 0 out to the curve, which is y equals 8 minus x, quantity squared, so it's the radius squared dx. We have to integrate this, so what I'm going to do is I'm just going to say it's like the quantity 8 minus x squared, so there should have been a negative from reversing the chain rule, and then plus 1 times the reciprocal, so we'll get pi, and then negative 1 from reversing the chain rule, and then 1/3 reversing the power rule, 8 minus x cubed, and then we are going from 0 to 8. So now we just have to plug in here. So we're going to plug in 8, and that actually zeroes this out. And then when we plug in 0, we get 8. So we have 0 minus 8 cubed. 8 squared is 64, so I need to do 64 times 8. Okay, 512. So we have negative pi over 3 times negative 512, which is 512 pi over 3. There you go. All right, let's take a look at another one. Y equals 2x squared, x equals 0, x equals 4, y equals 0. So here's what our region looks like. We're going around the x-axis, and so we're going to have this as the radius that we're going to square. So our radius is top take away bottom. It's just going to be 2x squared. So we're going to go pi, the integral from where we start to where we stop, which is 0 to 4, r squared. So the quantity 2x squared squared. Don't get fooled because there's already a squared there in r. We still have to square it. So this dx is just going to be 0 to 4 of 4x to the 4th dx. Now we're going to integrate, so it's going to be pi plus 1 times the reciprocal. So you're going to get 4/5 x to the 5th. And we are still going from 0 to 4. And so now we have to plug in. I will say this particular problem source has some really big numbers that you have to deal with. So we have 4 pi over 5, and then we'll have 4 to the 5th when we plug in 4 minus 0 to the 5th, which is 0. So we need to know 4 to the 5th. So 4 squared is 16, so 4 to the 4th is 256. So I need to do 256 times 16 because there's a 4 and a 4. So, I mean, you can work it out. Or, at this point, maybe you could just use a calculator. Scientific calculator would definitely help. So I get 4096 pi over 5. So this isn't really a video about arithmetic, so I'm not going to worry about that too much. All right, let's take a look at the next one. Y equals e to the x plus 1, x equals 0, y equals 1, y equals 0. You do want to know what e to the x looks like. Exponential function, very famous. Here's what our region will look like. And so we are going to go around the x-axis, and then we'll have this radius that we're rotating. So the radius in this case, top take away bottom, is just e to the x plus 1 minus 0 technically. So our integral will be pi. The integral, we're going from 0 to 1 because that's where we start and stop the region, r squared. So it's going to be e to the x plus 1, that quantity squared, and then dx. So in this case, we have to expand that. It's the only option. So we will have pi integral from 0 to 1. You get e to the 2x plus 2 e to the x plus 1, and then dx. Now we have to integrate, so it's going to be pi. That pi just kind of lurks around. The integral of e to the 2x is 1/2 e to the 2x by reversing the chain rule. The integral of 2 e to the x is 2 e to the x. And then the integral of 1 is x. Now we still need to evaluate this from 0 to 1, and you have to be really careful because e to the 0 is not 0. People tend to like universally think when you plug in 0, you get 0. Not always the case. So it'll be pi. When we plug in 1, we get 1/2 e squared plus 2e plus 1, which is not nice looking, but it is what you get. Minus, when you plug in 0, you get 1/2 e to the 0 is 1, plus 2 e to the 0 is 1, and then plug in 0 to x, you get 0. So we have this. Now we just need to combine everything. So we have pi 1/2 e squared plus 2e, and then you have 1 minus 2 is -1, and then 1, sorry, 1 minus 2 is -1, minus 1/2 is -3/2. That was like hard math. I don't know why. All right, let's take a look at the next one. We have y equals x to the 4th, x equals 0, y equals 1, and x is greater than or equal to 0. The reason that is there, they could have just said in the first quadrant, which is usually what they say, but if you graph the entire thing, it's kind of symmetric about the y-axis. This is the region that we're actually talking about. So in this case, we're going around the x-axis. We have an intersection point of 1, 1. You basically just said x to the 4th equal to 1, but you can definitely see in the graph that it's going to be 1, 1. Going around the x-axis, we're going to have a big radius, and we'll have a little radius. So our big radius is just y equals 1. Our little radius is actually just y equals x to the 4th. So in this case, we're going to have to do pi the integral. So we're doing big volume minus little volume, right? So you're going to go from 0 to 1. So the big volume will be the big radius squared. So that's the quantity 1 squared. Minus the little volume will be the little radius squared, which is the quantity x to the 4th squared. And then all of that is dx. All right, so we want to simplify this integrand, then we will integrate. So that's going to give us pi 0 to 1. We just have 1 minus x to the 8th dx. So now we will reverse the power rule. So pi, the integral of 1 is x, and then 1/9 x to the 9th. We're still going from 0 to 1. So we'll get pi. When you plug in 1, you get 1 minus 1/9. And then I like to show the step where I plug in 0, even if everything zeroes out, just so like for completeness, so that when I look back at my work, I can tell that I actually did the problem. So we get this, 1 minus 1/9 is 8/9. So we get 8 pi over 9. Let's take a look at number 78. We got y equals the square root of x is 0, x is 4, y equals 0. So this is just square root graph. And so we are going to go around the x-axis. We're going to draw in our radius. Once you do a bunch of these, you get very comfortable with it, I find. So the radius is just square root of x. So it'll be pi. We are going from 0 to 4. And then our radius squared, so square root of x squared dx. Simplify the integrand, which is kind of like always the next step. So pi 0 to 4 of x dx. We have to reverse the power rule. So there'll be pi 1/2 x squared going from 0 to 4. And now we have to plug in. So it'll be pi over 2 because of the pi and the 1/2. Plug in 4, you get 16. Plug in 0, you get 0. So 16 minus 0. And then 16 over 2 is 8 times pi. So 8 pi. All right, new problem. Number 79. So they kind of like get more interesting. Like I would say this one and the following two problems are like more interesting than the previous ones. We have y equals sine of x, y equals cosine of x, x equals 0. So you got to remember how to graph sine and cosine. That's going to come up throughout calculus. Cosine starts at 1 and then decreases. Sine starts at 0 and increases. It will look like this. These definitely intersect at pi over 4. Memorize the unit circle and you just kind of know that answer, which I think is definitely the best way to do that. So this will be pi over 4, and then each of them is root 2 over 2 at pi over 4. All right, so we are going to have a big radius, which is the cosine graph, and a little radius, which is the sine graph. So our big radius is the cosine graph, little radius is the sine graph. We're going to do big volume minus little volume. So we're going to go pi from 0 to pi, the integral from 0 to 4. Nope, I said that wrong every time. Pi times the integral from 0 to pi over 4 of big radius squared, so that's cosine squared, minus little radius squared, which will be sine squared. Now this looks a little intimidating, except cosine squared minus sine squared is famously a trig identity, so this is not as bad as you might be imagining. Cosine squared minus sine squared is the cosine of 2x. Highly recommended that you know that identity. Sine of 2x is also a useful identity. That's 2 sine cosine. So I'm going to replace the integrand with cosine of 2x. So we actually have this. This we can integrate by just reversing the chain rule, basically. So we'll get pi. So there should have been a 2, so 1/2, and then sine of 2x. And we are going from 0 to pi over 4. And so now we're going to have pi over 2. You get the sine of pi over 2 minus the sine of 0. Sine of pi over 2 is 1, and the sine of 0 is 0, so this is, pi over 2, and then you have 1 minus 0. So actually our answer here is just pi over 2. Okay, let's look at another one. So this is number 80. Y equals 1 over x, x equals 2, y equals 3. So you see this and you start thinking like, all right, somehow these three curves must define a region. So we're going to graph 1 over x, x equals 2, y equals 3. It looks like this. You can see there's only one region that is contained by all three of them. To deal with this, we are going to need to know where they intersect. So 1 over x intersects y equals 3 at x equals 1/3. So we know that this intersection point here is 1/3, 3. And as we do this, we're going to get a big volume from big R and a small volume from little r. So big R, in this case, is just y equals 3, and little r is just 1 over x. And so we're going to do big volume minus little volume to get our answer. So it'll be pi, the integral from 1/3 to 2, because those are the x bounds for this region. And then big R squared, so 3 squared, minus little r squared, so minus 1 over x squared, and then a dx. We're going to simplify the integrand, which gives us pi from 1/3 to 2, 9 minus 1 over x squared dx. Might be easier in your mind to think of 1 over x squared as x to the negative second for the purposes of finding the antiderivative. So we're going to do pi. The integral of 9 is 9x, and then if you think of it as x to the negative second plus 1 times the reciprocal is negative 1 x to the negative first. We have minus negative 1 times x to the negative first, so minus negative is plus x to the negative first is 1 over x, and we are going from 1/3 to 2. So now we just need to plug in 2 and plug in 1/3. So plugging in 2 gives us 18 plus 1/2. Minus plugging in 1/3 is going to give us 3 plus 3. And then we need to simplify this. So this will give us pi. You get 18 minus 6 is 12 plus 1/2. So overall, we are getting 25 pi over 2. And there is one more that we're going to do in this video. So let's take a look. This one is like a kind of like next level compared to the previous ones, in my opinion. So first we have x squared minus y squared equals 9, which I look at that and I'm like, that's a hyperbola. And it's a hyperbola, it's like eating the x-axis because x goes first. And then also we know that y and x are both greater than 0. So for this hyperbola, the only part we really care about is this kind of like first quadrant part. And so that's going to be, a part of our region. And then also this, I'm going to make y equals 9 minus x. Now I'm going to sketch the region or let the computer do it. So this is the region that we're dealing with. I'm going to split it up. So we're going around the x-axis. I'm going to split it there at x equals 3 because we have like a different, that little r gets involved. There's actually two ways I could have done this, and I think I don't like the way I did it, but whatever. So I'm splitting it there, and on this region, we just have a big R. There's no little r. On the second region, we have a big R, which is really the same as the previous big R, and then we have a little r. So we're going to do two volumes and then just add them together. Our intersection point, you can kind of see is at 5, 4. You really have to take x squared minus y squared equals 9 and set it equal to, x squared minus y squared is equal to x plus y, and then solve from there. But you can just see that it's 5, and also there's something very Pythagorean about this. 3, 4, 5 is kind of hanging around. All right, so the first region, big R, is just 9 minus x. And then for our second region, big R is again 9 minus x, and little r is going to be something we need to work out, right? So little r is that hyperbola. So we start with x squared minus y squared equals 9. I'm going to rearrange that, and then I'm going to solve for y. So y is the square root of 9, no, the square root of x squared minus 9. So that's our little r. All right, from there, it's straightforward. We're going to set up our integrals. So the first one, we're going from 0 to 3 of big R squared, and then dx. And then we're going to add to that pi, the integral from 3 to 5, and then it's going to be big R squared minus little r squared. And now we need to evaluate this. At this point, I kind of realized what I really should have done is just big R from 0 to 5. So I'm going to rewrite this a little bit as pi, the integral from 0 to 5, because we're going 0 to 3 and 3 to 5 of the same thing, so we should combine those. So 0 to 5 of the quantity 9 minus x squared dx minus pi times the integral from 3 to 5 of this part here. So this is what we can simplify it to. So what I'm going to do is I'm going to just integrate. I'm going to do u substitution on this one, where there should have been a negative to because of du, and then plus 1 times the reciprocal gives us 1/3, then from 0 to 5. And then we'll have minus pi, and then because we're squaring a square root, we're going to get x squared minus 9. So integrating that gives us 1/3 x cubed minus 9x. Going from 3 to 5. This problem, like I mentioned, is like way more annoying than the previous ones in my opinion. So we have a negative pi over 3. We have to plug in 5, so that's going to give us 4 cubed, which is 64. Then we have to plug in, so minus. Plugging in 0 gives you 9 cubed. 9 cubed is 729, which you either know or you can work out, or I think you could use a scientific calculator on this. Minus pi. When I say scientific calculator, I mean just like do the arithmetic on your calculator. When we plug in 5, we get 125 over 3 minus 45. And then minus, when we plug in 3, we get 27 over 3 is 9 minus 27. And then I just use a calculator for this. This all combines to 207 pi, which apparently is the volume when this region is rotated about the x-axis. All right, so that's a whole bunch of problems. I hope this was helpful, and good luck.